Okay, so let's look into the introduction. University laboratories are environments where teaching, research, and innovation take place simultaneously. These laboratories are used by students, postgraduate researchers, and technical staff, all of whom may have different levels of laboratory experience. As a result, university labs face various risks, including biological contamination, chemical exposure, and hazards related to laboratory instruments. In Malaysia, activities involving biological materials are regulated primarily under the Biosafety Act 2007, which governs the handling of biological agents, genetically modified organisms, and biological waste. This act is supported by the Occupational Safety and Health Act 1994 to ensure both safety and quality in laboratory operations. And therefore, the objective of this study is to integrate the laboratory safety practices and effective instrumentation management with compliance to the Biosafety Act 2007 within Malaysia University laboratory context.
Hello everyone, my name is Edward Johnny, metric number 73425. Today I will be presenting the literature review. These are the points that will be mentioned in my presentation. Advances in biotechnology have increased the use of genetically modified organisms and biological agents in academic laboratories. While this supports scientific progress, it also raises biosafety risks, making proper management essential to protect researchers, the environment, and public health. In order to manage this risk, Malaysia introduced the Biosafety Act 2007. This act regulates activities involving living modified organisms and ensure protection of health and the environment. Academic and research institutes are legally required to comply with this provision. The Biosafety Act is enforced through the National Biosafety Board and institutional biosafety committees. While the board oversees regulation nationally, IBCs ensures a compliance at the institutional level by reviewing research activities and monitor laboratory practices. Effective biosafety compliance also depends on laboratory safety culture. Factors such as training, awareness, leadership, and communications influence how well safety procedures are followed, especially academic laboratories with users of different experience levels. Next, instrumentation management is vital in supporting biosafety. Equipment such as biosafety cabinets and also autoclaves help prevent biological exposures. Proper use, routine maintenance, and calibration are necessary to ensure both safety and legal compliance. Integrating biosafety legislation with laboratory management requires coordination between policies and also daily practices. Institutions use SOPs, safety manuals, and training programs to ensure compliance and maintain accountability. Despite comprehensive regulations, gaps still exist in practical implementations. Rapid technology advances, limited resources, and training challenges highlight the need for a holistic approach that integrates legal compliance, safety cultures, and effective instrumentation management.
Malaysian regulation and SOPs are applied to all instruments involved to ensure the safety of the user according to OSHA 1994 following Biosafety Act 2007. Instruments such as UV visible spectrophotometer, high-performance liquid chromatography expose the user to a certain risk that varies depend on the instrument. So the risk exposed from spectrophotometer is high-intensity UV radiation and chemical spill, and from HPLC it can have a high pressure leak and flammable solvent leak. So the safe handling practices to use this instrument is to first use a latex glove usage and conduction at a safe eye distance. And for HPLC, it can also be conducted with no heat source nearby. And standard safe handling practices must be incorporated firmly to employ it according to Biosafety Act 2007. Risk assessment, Malaysia implements HIRART system as a systematic approach to prevent hazards. There are three levels, which is hazard identification, risk assessment, and risk control. For the first step, hazard identification is to recognize potential causes, either from the surrounding or from activities that can lead to the hazard. So for the second level is the risk assessment, which is an evaluation of probability and severity of hazards, which will be classified into their own classification and priorities. And for risk control, it is a hazard preventive measure which require the usage of machines, the SOPs and training, and also personal protection equipment. Technology-based organizations are required to follow the law emphasized on Biosafety Act 2007. For example, for the GMOs regulation and waste handling procedure. So for GMOs regulation, it has permits for importation, exportation, risk assessment, public consultation with NBB, labeling, adherence to precautionary principle, and risk management and activity logs are required. So for waste handling procedure, it requires a containment procedure and hazard preventive measures, decontamination, segregation, and authorized method.
This is the summary of compliance checklist. Biosafety Act 2007 compliance with laboratory safety and instrumentation management in academic or research settings. So for the first point is IBC and biosafety approvals. This section explains that laboratories must establish an IBC or Institutional Biosafety Committee, and all biological and GMO related activities require official approval. This is to ensure regulatory oversights and legal accountability as required under the Biosafety Act 2007. Second point is Risk Assessment and Control or HIRARC. This part shows that hazards must be identified. Second, must be assessed. Third, control measures must be implemented. HIRARC ensures that biological, chemical, and physical risks are systematically managed, aligning with OSHA 1994. Third point is instrumentation management. This section highlights that proper maintenance, SOPs, and calibration of laboratory instruments. Safe instruments prevent accidents and ensure reliable research data, supporting both laboratory safety and MS ISO/IEC 17025 2017 principles. Fourth point is personal training. This explains that laboratory users must receive biosafety training and safety awareness must be continuously reinforced. Well-trained personnel reduce human error and improve compliance with biosafety and occupational safety laws. Fifth, waste management. This component shows that proper segregation, decontamination, and disposal of biological waste. This prevents environmental contamination and protects public health in line with Environmental Quality Act 1974. Sixth point is emergency preparedness. This section explains that laboratories must have response protocols for spills and incidents. Preparedness reduces the severity of accidents and ensures rapid and controlled response. Seventh is that documentation and records. This highlights record keeping, SOP documentation, internal audits, and compliance reports. Documentation provides traceability, accountability, and audit readiness, supporting continuous improvement. This is my summary of discussion. Challenges in implementing biosafety compliance. First point is that limited awareness and safety culture. Low awareness of Biosafety Act 2007 among students and researchers. Uneven understanding of biosafety procedures and PPE usage. Students more familiar with general emergency than biosafety specific practices. Compliance often documented but not practiced. Second point is that financial and infrastructure constraints. Restricted budgets limit biosafety equipment and facility upgrades. Inadequate biosafety cabinets, waste treatment and instrument maintenance. Laboratory space in facility design limitations affect safety culture, and teaching and research priorities reduce biosafety investments. Third point is that challenges in HIRARC implementation. Academic labs have dynamic experiments, complicating risk assessment. HIRARC often rush, outdated, or poorly reviewed, and lack of dedicated safety personnel causes inconsistent enforcement. 4 proposed improvements to overcome biosafety challenges. First one is structured biosafety training. Compulsory biosafety training for all lab users. Regularly refresher sessions and hands-on emergency drills, and integration of biosafety education into academic curricula. Second is strengthen institutional governance. First, empower IBC or institutional biosafety committees. Second, active compliance monitoring, audits and corrective actions, and educate staffing and institutional support. Third point is that sustainable resource allocation, continuous investment in biosafety infrastructure, proper instrument maintenance and waste management systems, and educate containment facilities. Fourth point is that continuous improvement and monitoring, routine internal audits and proper documentation, performance monitoring of biosafety practices, and integration of biosafety into daily laboratory preparations.
In conclusion, maintaining a safe and productive research environment requires a combination of strong biosafety governance, continuous training, and a proper management of laboratory equipment. By integrating legal compliance, a positive safety culture, and well-maintained instrumentation, academic institutions in Malaysia can ensure that research is conducted responsibly and safely, ultimately supporting scientific advancement.